All right, everyone. Today we're going to tackle a skill that shows up everywhere in algebra, subtracting polynomials. Now, I know the word polynomial can already raise a few eyebrows, but the good news is this is really just organized subtraction. No magic, no new math tricks, just careful steps. By the end of this lesson, you'll know exactly how to subtract polynomials. You'll see two solid methods you can choose from, and you'll understand the most common mistakes so you can avoid it completely. When we subtract polynomials, we're finding the difference between two algebraic expressions. Think of it like subtracting regular numbers, but now the numbers have variables attached. The key idea here is that we change the signs of the second polynomial and then combine like terms. Like terms must match exactly, same variable and same exponent. For example, 3x squared and negative 5x squared can be combined, but 3x squared and 3x cannot. This idea shows up constantly later in algebra. So getting it right now saves a lot of frustration. There are two rules you want burned into your brain here. Rule 1, group like terms. Organization matters. Messy work causes mistakes. Rule 2, and this is the big one, change every sign in the polynomial you are subtracting. Positive becomes negative. Negative becomes positive. No exceptions. Once you do that, subtraction actually turns into addition, which is why this process is much friendlier than it first looks. The horizontal method keeps everything on one line, which makes it great for shorter, simpler problems. First, write the subtraction clearly using parentheses. Second, change every sign in the second polynomial. Third, remove the parentheses. Then, group like terms and combine. If you follow those steps in order, this method is quick, clean, and reliable, especially on quizzes and tests. Let's walk through this example together. We are subtracting 4x minus 10y plus 15z from 5x plus 8y minus 20z. Step 1, write it clearly using parentheses. Step 2, change all the signs in the second polynomial. This is the moment students most often rush. Now remove the parentheses and regroup the like terms. Once like terms are together, the math itself is easy. Our final answer is x plus 18, y minus 35z. Notice how the hardest part was not the arithmetic. It was being careful with the signs. The vertical method looks a lot like subtracting multi-digit numbers, and it works especially well for longer polynomials. You line up like terms in columns, fill in missing terms with 0, change all the signs in the polynomial underneath, and then add column by column. This method keeps your work neat and makes it much easier to avoid mistakes when things get complicated. Here we see the vertical method in action. We line up the x squared terms, the x terms, and the constant terms. Next, we change all the signs in the polynomial being subtracted. Now it becomes simple column math. The x squared terms combine, the x terms combine, and the constants combine. Our final answer is x squared minus 22x minus 25. Same result you would get using the horizontal method, just a different organization. Here are 4 habits that make a big difference. First, always write polynomials in standard form with terms in order from highest power to lowest. Second, double check your sign changes. This is the #1 mistake students make. Third, choose the method that fits the problem. And finally, verify your work. Ask yourself, does this answer make sense? A quick check now saves a redo later. Now it's your turn. Try subtracting 3a squared plus 5a minus 7 from 7a squared minus 2a plus 4. I encourage you to try it using both methods so you can see which one feels more natural to you. Remember, rewrite it clearly, change those signs, and take it step by step. To wrap things up, subtracting polynomials really means adding the opposite polynomial. You now have 2 strong methods in your toolbox and the confidence to choose the one that works best. With practice, this becomes automatic and it sets you up perfectly for more advanced polynomial operations. Stay organized, trust the steps, and remember, algebra rewards careful thinking.